Okay, number 1A. 23 pi over 12. Why don't we actually just practice drawing it first? Where would you locate that angle? 23 pi over 12. 23 pi over 12. Okay, did you put it there? Because it's just a little short of the 24, which is the doubled. Okay, this is therefore a 15 degrees in that zone, which I call that reference angle. So, how do I get 15 degrees using only these values? Which combination do you want to do? 45 minus 30? Okay, so that's what I'm doing. I'm doing the sine of a 15-degree reference amount. So now I'm going to take this and look at my formula sheet. So sine of 2 subtractions. So can you find that on there? So sine A cos B minus. Okay, everyone's good with the formula? Now, the next thing I do is I give myself 4 brackets so that I'm just ready to fill in those values. And I kind of cheat a little bit because I know at 45 degrees, it doesn't really matter what I am. I'm root 2 over 2. So root 2 over 2 at 45, don't need to think about anything. Sine cos. All right, the cos of 30 is the x number. The sine at 30 is the y number. Okay, and then I'm going to put this together. So this is a root 6 minus a root 2 over, they're all over the same bottom, 4. Last thing here, what do I know about the Astica stuff going on with sine there? It's negative, so I throw brackets on that and negate the value of it. Okay, another question I just might ask you with this 15 degree, 75 degree is, could you find me a coterminal angle to that? Anybody know a number that would be coterminal to this? Negative pi over 12 is coterminal. Yep. What's another one that might be a positive coterminal? What would be the next positive coterminal? 47 pi over 12. Okay? So all I was doing to the 23 was either adding or subtracting 24, because 24 pi over 12 is a full circle of 2 pi. Okay, so I might just randomly ask you a coterminal question. Okay, 10. So let's draw 105 degrees. Where would you draw that? So 105 degrees. So I have a 75-degree reference. That's what that would mean. So I'm going to now do the tan of 45 plus 30. So you're always trying to get 45s and 30s here. So the formula for tan plus, down here, so tan 45 plus tan 30. Okay, I'm going to go over to the side here. What is the tangent of 45 degrees? Quickly, what is it? 1. The y divided by x will make 1. The tan of 30 is the y divided by the x. What happens with the flip multiply in the 2 situation? They're going to cancel. So we're going to do that. So I'm going to simplify that on the side, and then I'm going to plug this in. Okay, so we did that on the side. Okay, now I've replaced all those trig values with the proper spots. Okay, so I need to add this, which means I need to have the same denominator. So if I need a root 3 on the bottom, I'm going to need a root 3 on the top. Okay, so I just changed the looks of a 1. Root 3 over a root 3. Okay, I'm going to also do the same. Okay, we're all okay to understand why I'm changing the 1 to look like that, so that my bottom is the same. So this is going to make a root 3 plus 1 over root 3. So there's my root 3 plus a 1 over root 3. And this is going to make root 3 minus a 1 over a root 3. Are we okay if I short this again? The flip multiply makes that cancel. Okay, that flip multiply will cause that. Last, we have to talk about our astica. So the tan in that quadrant is negative. So I bracket the whole thing and negate the value of it. Okay, question C. Draw that first. 17 pi over 12. Okay, did we find the same spot? This would make it a 75 reference. So I'm going to go with a 45 plus 30. And I'm not doing secant. What should I do instead of secant? Cos. So the formula, I'm going to find the formula. find the formula for your formula sheet. Give yourself 4 brackets to fill in numbers. And why don't you just do the 45s first so you don't have to think? Root 2 over 2. Cos is the x value, y for the sine value. Okay, when you're done though, we have to change it back to the question. So we were secant, so I'm just going to flip that around because we were secant. And I also should look at my astica stuff. So in that quadrant, cos is negative. Okay, so don't forget to look at that at the end to see if you need to negate that or not. Okay, so that is the recap on your 75 and 15-degree angles. Okay, we were given the sine of an angle and it's in quadrant 2. So here's my drawing. So can you place a 5 and a 13 on that triangle for me in the right spots? Which side length is 5, which side length is 13 using a sine ratio? Okay, so that should be your triangle, 5 and a 13. What is the bottom side if you have this triangle memorized yet? 12. Then we talk about location. Okay, Pythagorean, but then understand its location. So now I'm just going to write here, I know the sine of this angle is 5/13. And I'm going to also write the cos ratio. So now we know how to get that. Cos is x over the r. Okay, so there's the work I want. Okay, cos 2 theta. You have 3 options, and it does not matter. So I'm going to go with the first one. I have no reason to pick that over the others, but okay, so I picked that formula. So the cos value is negative 12/13, and the sine value is 5/13. Okay, what happens to this, positive or negative? Positive 144 over 169 minus 25 over 169, which ends up being, what is that on the top? 119 over 169. And it makes sense that that value is positive, because if you think about an angle, I don't know where exactly it is. If you think about doubling that angle, which quadrant would you land in probably? You doubled it, you would land over there, right? Where cos is positive now. Okay, sine 2a, or sine 2 angle. So this is the formula. There's only one option. So find it on the formula sheet. So 2, I'm going to write it as 2 over 1 just to help my brain organize stuff. Fill in the fractions. You already did the work. Okay, what do you think? Positive or negative? Negative. We got a 10, and then times that. Are you getting a 120? And then 169. And that also makes sense because I figured if I doubled my angle, I would land in the quadrant 4. If I was to ever ask you this question, what would you do? You would take the sine of the double angle divided by the cos of the double angle. You would just take that sine value divided by cos value. And then, if you could shortcut this and flip multiply, what does it end up with? Okay, so how do we work backwards from formulas? So question 3, there's some of these on your test, working backwards. So which formula looks like this? Cos, cos minus sine, sine. Which formula looks like that? Cos, cos. So this one, cos A plus B. Cos A plus B. So you get 1 point for that on your test, and then 1 point for actually figuring it out. So find the exact value, so we're looking for a trig value. So cos of 8 pi over 24. Okay, I added the 3 and the 5 there. I don't feel like I recognize that angle right now. Right? It's not a unit circle number. What can I do with that fraction though? It's just math, basic math. What is there to do with that fraction? Reduce by 8. Oh, that looks better. Now I recognize something. Or what if you were on the test and you were really stuck? What else could you do with this? You could figure it out to degrees, right? You have a calculator. You could times by 180, divide by pi, right? That's another thing you can do if you're stuck. Okay, so you can reduce to get something you recognize, or you could change it to degrees to recognize it. So at pi over 3, what is the cos value? 1/2. If you try to literally just do calculator work and showed me nothing, you will get a 0 score. So if you tried to type that into your calculator, just typing it in, yeah, it would give you a 1/2, but I will give you 0 points. Okay, sine cos minus cos sine. What does that look like on your formula sheet? Sine cos minus, I think this one, right? Sine A minus B. Sine A minus B. Sine of A minus B. Which is, once I subtract, it's the sine of 45 degrees, which is what trig value? So that's what this says. What's the exact value? What's the trig value? So at 45 degrees, the y value is root 2 over 2. Okay? So all that is the last, once I get past this, this is all last unit, right? Okay, we have been given an A and a B angle. So we have two things going on. We're going to have two diagrams. They're in the same quadrant, so we have to figure this quadrant stuff out. Where could angle A possibly be located? Cos is negative. Where could it be? The left-handed side. Sine of B is positive, so angle B is in either the top one or two. And now it says these two angles are in the same quadrant, therefore I've concluded they got to be in quadrant 2. Okay, so I'm going to draw stuff for A. Can you put that on the triangle somewhere? Where does the negative 8 go? Where does the 17 go? And the last side of that, if anybody came up with another calculator, is it 15? Pythagorean 15. And is that a plus or a minus the way it's located? Plus. Okay, we just better make sure we double check. So let's go, oops, the sine, not the cos, I already had that. The sine of A is 15 over 17. Okay, let's go through the same process with B. So we said it is also in quadrant 2, and we were told the sign of it. Okay, so that's stuff we were told about it. It's in quadrant 2, and there's the sign. Can you put that on the triangle? So 24 and 25. And, did anybody already do it? Square root? 7. But we need a negative 7 on it because it's location. Alright, so this is going to be the cos ratio of negative 7 over 25. Okay, all that was just background work, and all that was from Unit 1. So now let's figure out what to do with that. Okay, so the formula is cos A minus B. So I got my formula sheets, and cos A minus B says So I'm just going to copy that formula down. Okay, I personally like to make brackets so I know to myself I got to insert some exact values in there. I got to replace those 4 things. Okay, and we have everything already down here at the bottom, so can you fill in where you want to put stuff? Something good when you're doing this is just to double check that you've used no one of those twice, because you should have used all of them at one point. Okay, so that bottom 17 times 25 is a 425. So now it's just get your top numbers as well. So a positive 56 and a positive 360. Okay, so now basically do the same thing. Sine A minus B. Find your formula. And I'll let you finish this one on your own. Find your formula, replace, and finalize. All right, trig groups. All right, where to start? So, do you think I want to make any substitutions? Can I substitute anything? I could maybe make a substitution on this side. We could do that. So on this side, I could replace cotangent with a cos t over a sine t. Okay, I don't think I can substitute anything else, right? What else? Is there any canceling, conjugates, common denominators? Do you see any of those strategies? I need a common denominator because I'm working with 2 fractions and I would like to have a goal. Look on this side. My goal is that I'm ending up with 1 fraction. So if I have 1 unit, I somewhere need to put these together. That's I kind of look at the answer on the other side to see where am I going, right? That's my goal. So what do I need to include in my denominator? I'm going to need a cos t and a sine t. Okay, looking at this first unit, did you do anything different to the bottom? No. So I don't do anything different to the 1. Looking at this second fraction, did you do anything different to the bottom? Yeah, it would have got times by sine t. So I'm also going to times the top by sine t, creating a sine squared. Okay, so there's a strategy, a common denominator to group fractions together. Now, what do you see? I see a substitution. Is there something from your formula sheet that you can replace that with? Cos squared. Okay. Now I'm allowed to do a cancel. Because everything is connected with multiplying and dividing, I can do some cancels. So I'm going to cancel a cos out of the top and a cos out of the bottom. And I'm done. Okay, I would say that that would be an easy leveled one. So you wouldn't see that easy on your test. I'm going to try to do an easy medium and a medium. Okay, what are we going to do here? So my first instinct would be what? Actually, I have three choices I could go with, I think. Does doing a conjugate get me anywhere? A conjugate would be doing a 1 plus sine theta. Does replacing this with sines and coses get me anywhere? Or does replacing cotangent squared with this get me anywhere? Which of those three strategies? So I'm seeing all of those things. What one do you want to do? Anybody have a hint? Did you see anything? So this is what I'm visualizing because I always have to think a couple steps ahead. Here's what I'm thinking. If I replace cotangent squared with this, okay, I feel like I could factor that as a difference of squares and get somewhere with a cancel. Can you see my thoughts 3 steps ahead? Okay, so I'm going to replace. So let's make a substitution. I might actually try this in 2 different ways and see if we can do it in 2 different ways. Okay, so that was from the formula sheet. Now I'm going to do a factor. Okay, so I'm going to factor that using a difference of squares. So 2 brackets, cosecant theta at the starts, and a plus minus 1. Whoops, I'm writing the wrong stuff here. Why am I writing cos? So there's my factor. Now I can do a cancel, because it was this times this divided by this. There was 3 units involved. So I can cancel. At this point, you can probably work from either side. You can maneuver cosecant into a 1/, sign if you want to do that. I'm going to jump to the other side just so I hit the other strategy, which is split the fraction. So I just want to show you that as well. So that's me splitting that apart. Okay, again, usually we're like this and working to get 1, but we're splitting. So this is now cosecant, and that's 1. That was probably an easy medium. Okay, you know what? I'm going to try this. I have no idea if it's even going to work. This is the strategy I would have gone with. I'm going to try doing my replacements with cotangent and cosecant and see what happens. Okay, so cotangent squared would be, what's cotangent? Cos over sine. So obviously those are squared because that was squared. And then I'm going to replace cosecant Okay, so if I had been a person who just started like this, because that was my instinct, then let's see what happens. Okay, let's put this together with that. So are you okay if I replace 1 with a sine theta over a sine theta so that I can make it with the same bottom? So I'm going to be putting that together. Okay, does everyone follow what I did there? I just put that together as one unit with a common denominator. Okay, now I would multiply all that around. Okay, this is going to get there. Flip multiply. I can now cancel this sign with one of those signs. So that was a cancel maneuver. Now what? I'm trying to get to that other side. Do you see what's going on? There's no coses in this, so I need to think, what could I do to get that cos stuff out of there? I could substitute We're almost there. What now? It's something to do with this. What else could you do with that? You can factor it. So difference of squares. So 1 plus sine theta, 1 minus sine theta. Cancel, and you did it. 1 minus sine theta over sine theta. Okay. Okay, so you can see how person A did it one way, person B did it another way, and I got there. Obviously this way took a lot more algebra than that way, but sometimes this is always somebody's first instinct. Just get everything to coses and sines. Okay, this is not working for us because there's cotangent stuff, there's cosecant stuff. That's not good. Is there anything I can replace? What do you always look for when you're replacing stuff? You're looking for the squared stuff. That's your hint, the squared stuff, and the reason is everything in this corner involves squareds. So cotangent squared, that's what I could replace it with. Okay, so that's my replacement. And then I'm going to continue to write the rest. Okay, now I'm thinking this next. I'm going to put some like terms together with each other. Okay, so now this is that algebra branch all the way from grade 11. The first thing is I have two variables, so equals 0. So we're there. Second thing, I try to factor. Is this factorable? So I'm going to attempt to do a simple trinomial. Does 3 times 1 end up making an add of 2? So that would work, right? Simple trinomial works. So now I'm going to get what I would call the trig values. So I'm kind of looking for things like this when I'm grading. Did you do a substitution of what you needed to from your formula sheet? Did you find your trig values using your grade 11 algebra skills? Now, a bunch more points for all the angle stuff. So please don't stop there. You're going to get like 25% on this problem if you stop at the trig. Okay, cosecant is going to switch. Okay, please don't drop the negative. It's not like you change something to positive and negative. What's the flip of 1? When I flip 1 around, what happens? Still 1. Okay, I'm going to first think, where am I? So sine negative. That's my first instinct. Where am I? The next is I have to understand how am I answering this. So this says in radians. So I'm going to sine inverse 1 divided by 3 in radian mode. That's what I'm doing in my calculator. I have to make sure it's in radian mode. I'm going to sine inverse 1 divided by 3. Then my last step is to finalize it. So I'm going to do pi plus that number. And I'm leaving everything in my calculator as I'm going along because I have to stay with 3 decimal places the whole time. Okay, and then I go over to sine of an angle of 1. Ooh, that's on a unit circle. The number 1 is on a unit circle, so I'm not going to touch my calculator. Where is there a y value of 1? Are you thinking in that location the y value is 1 up there? So that I'm going to answer as pi over 2. And if somebody answered me in decimal, I would accept that as a full point answer. I just wouldn't be as impressed, but I would accept it as a full point answer. But when I see answers like this, then I know that you're thinking about your unit circle. Okay, last question. So again, we start with the problem of there's sines in here and coses in here. I don't like that. So there's going to be a substitution I'm looking for. And my eyes are always going to go towards the squared. Okay, so I found something on my formula sheet to replace that with. This time I better make sure that I'm understanding there's a 2 times in that. So it's going to cause a 2 to times that whole unit. Okay, so 2 times that whole unit, so I'm going to go 2 minus 2 cos theta, or squared theta, okay, now is the time to think about algebra. So right now I have cos squareds and coses, 2 variables. I need this to equal 0. Who is the boss in this whole thing? This term is the boss, and it's negative. So I don't like that. So I'm going to be putting everything to this side. So I'm going to go 0 equals. So if I move this, it's going to be a plus 2 cos squared. And if I move this, it's a minus 3 cos. And for some reason on this test, when students are moving stuff, this is actually where I get most of my mistakes. What is the number? Did you put a plus 1? Okay. So be concentrating on that. For some reason, that's where I get the most mistakes. And if you end up with mistakes there, it will make your life a lot harder. Okay, let's see if this factors. If it doesn't factor, what would I do? Quadratic formula. Okay, don't forget that. Sometimes I give you too many factoring things that you forget that. So 2 cos and a cos. Well, that has to be a 1 and a 1. Does it end up working? I think that would get me there, right? So now I'm going to get my trig values. So that's just my trig value stage. and it has not even started the angle stage yet. Okay, I actually don't even want you to touch your calculator because you can do this whole answer without your calculator. First of all, let's just check up here. This says to answer in degrees, so I have to answer in degrees. So where is cos a half? Where are you even looking? I'm looking here, so 60 degrees. So my eyes were there at 60 degrees. And the other x of a half is at, do you think, find it at 300? And where is the cosine or the x value 1? In this side, over there. How will you answer this according to your domain? You have to say 0 and you have to say 360. Because you can include 0 and you can include 360. Okay, one extra thing just before you close that. What if I asked you for all real answers? If I say, what are all the angle answers? What would you do to that situation? Plus 2 pi k kei. So just don't forget that because I didn't do an example like that. So if I had said something like that for answer for all angles or all real answers,